Architecture. And then we will have source files. I'll share my screen. So anybody remember the medallion architecture from the last week? Okay, Ramya, talk about medallion architecture. Am I audible?
Yes, we can hear you.
Okay, that's fine. Okay, let me review the medallion architecture with you guys, because either it is ETL or data engineering. That's going to be the basic, um, how we progress and program our ETLs, right? So, um, so basically, the medallion architecture talks about, just like in the medals you have. Sharing, it's gone. Okay, let me share it back. Okay, let's look at here, right? So medallion architecture. What does it say? I mean, it's basically the same, the medallion that we have been doing for a long time. Sorry, for the ETL, right? So you extract the data, you process and you transform, and you load the data, right? So basically that's what the ETL, traditional ETL is. So even here in the medallion architecture that the organizations have adapted over the last few years for modernization of the ETL platforms. So same thing, you have ingestion. Ingestion sources are basically different, right? So you may have files coming from multiple sources, coming from different departments or different organizations or third party vendors. The files are coming into a server, and then you want to read, process, and put the data into a database. Or the third party may have their own databases, MySQL, SQL Server, whatever. You have a JDBC connection, you connect to them, you read the data, again transform it and load it. You have streaming sources, something like IoT data, sensors sending you the data, like weather data or the temperature and pressure, these kind of data points that is coming from aeroplane, right? So this is a continuously streaming data that is coming in. You want to process the data in flight, and then transform the data and write it to a database. So these are different sources. There can be many sources like this. If you are reading from a cloud, you are reading from a website, you are scraping the data out of a website, you process and then you put it. And then you have streaming data that is coming in, like credit card transactions. Somebody is, there are millions of transactions happening parallelly, and you have primary vendors like Visa and MasterCard. There you have millions of transactions coming in. You have Netflix, or any of the streaming platforms that users are watching, and then the data is continuously sent back to the servers. What programs they are watching, what video they are streaming, and all of that, right? So all that data is processed and then stored. So when you process and store, you need to have a standardization, right? So for standardization, first what you do, you create a bronze layer, silver, and gold. This kind of, it can be just virtual. You need not like physical thing. All three can be just same database, different schema names. Bronze is raw data. Basically, it is as close to the source as possible. You don't do anything. You just read and dump in the bronze. So the raw data is same as your source data, so that you have a data lineage. You go back to the source, you look at the data, and then figure out what happened, when it happened, at any given point of time, what data was written, what data has come in, and all of that. So this will be your point of start, and it will act as a historical snapshot, right? So raw data, of course, you can always have multiple snapshots, and uh, you can archive and purge data. But then from bronze, you read the data. Okay, the data can be delta, so daily or hourly or streaming, whatever batch that you want to do. Let's say I want to, so this entire thing can be a batch. We can run every night, or we can run twice or thrice a day, just like you schedule the jobs, or you can do hourly, whatever it is you want to schedule the jobs. So you schedule the jobs, you read the data, put it in the bronze, and then from bronze you read it. Then you transform the data. So what is the transformation? You filter and clean the data. Suppose you get a lot of data which you don't need. I mean, some of the data you may not need. So for example, you are getting a logs, system logs. Okay, systems logs will spit out a lot of information, or network logs will spit out a lot of information. But you may not need all the data. Okay, so you want to enrich and filter and get what is the data that you're looking for exactly. Like say, I only want a timestamp, start date, end date of the event, IP address of the event where it generated, or username, or the person who has generated that event, right? And time zone, or the location. So maybe this is the important information that I want to extract from that data. So what I will do, I will filter and clean the data. For example, time zones. They can be in multiple time zones, right? So they can be in GMT time format. They can be local PST, EST time format. They can be DDMM5 format, MMDD format, whatever it is. So they can be different formats. So we want to standardize. So convert everything into a common format. So that transformation we will do for the timestamps. Then locations, the zip codes, the addresses might be in a different format. So you can enrich it to a standardized uh, postal format address, right? So with a proper zip code, and then you and transform the data. If it is sometimes the state name is spelled incomplete, like Texas, sometimes it is TX, right? So all of those you transform. So transform and standardize into how you are storing. So once you transform and store the data, then you get into the gold layer. So this is basically ready to serve kind of a thing. Okay. So you have all your data in the silver layer transformed. Now you do aggregations or joins, and then you serve to the business or models, right? So what is this gold layer? This is the single source of truth. So once you have enriched all of this data, maybe you want to aggregate what are my sales data or revenue data each quarter or monthly or by day that I want to aggregate. So I will put the data here so that my BI tools, so analysis, reporting, or whatever, they can directly read from those views or tables, and then they generate the dashboards. Okay, generally gold is your business presentation layer. Sorry, this is the presentation layer. So this is the data serving the presentation layer. Also, it can be used for feeding the data science ML models for further machine learning and everything. But I think most of the times it's only used for analysis and reporting. Data science ML, unless they need more detailed, more granular data, so sometimes they go back and read from the silver, right? So they need to process at a granular level to understand and apply the algorithms to do any prediction or classification kind of a thing. for the data and ML algorithms. So they sometimes go to silver, and rarely sometimes they also go to bronze, even if they want the complete raw data to work with. So data science ML is different, but however, the point is the same. The data that you prepare can be used for analysis, reporting, data science. This is your serving layer. So basically, from left to right, you are improving the data quality and enriching the data, giving it a meaning. Okay. So this is the standard medallion architecture that is adopted in the data engineering. Okay. Any questions on this? Anybody? Guys?
No, Harun.
Okay, so we are all good, right? I know some of you already have some kind of experience with this, but I'm just reviewing it and for the benefit of uh, people who are new or who didn't have earlier experience on these platforms. So remember this, okay? This picture, remember, this is what you will be continuously using and talking about. Okay. So any interviews you talk in the data engineering space, you should always mention this. Yes, I have worked with, I have worked in the medallion. I have adapted or designed or implemented the data ingestion or data engineering pipeline or data analytics pipeline using the medallion architecture. Okay, and then bronze, silver, gold. As I said, it's only for the namesake. You can name it anything. Okay, you can say raw processed gold or raw processed final or stage 1, stage 2, stage 3 or something like that. But it's not the same as um, you know dev, test, prod. No, it's different. Okay, so in dev you will have these three layers. In test you have all these three layers, and production also you will have all these three layers. Basically each environment will have these three layers because that's how you process in each environment and get to the final data. Okay, remember that. And then you should talk about various multiple ingestion. You should always talk about we got sources from different data sources. You should talk about we got files, we have databases, and then here something you also get from streaming tools like Kafka, Kinesis, and other tools also that will give you data. That's also very common in the organizations. Okay, so you should talk about that. And then we processed, and then we created aggregates, and then you can say, and in the BI, you can say we had a Tableau or we had a Power BI that was reading from the gold layer for the creating the dashboards kind of a thing. And then you should say the data science and ML, it was, they needed data more granular, so we provided that kind of data from the silver layer instead of gold layer. You can talk about it. It's not standard. Nobody will tell you, say, hey, why are you reading from silver? You should only read from gold. So there are no hard and fast rules. It's all about how your business processes are structured and what is your use case. Okay. In fact, that will give you more credibility if you say, hey, our business use case was different. Okay, they didn't want to read anything from gold. They wanted raw data. So we provided most of the data from the silver layer. We created specific tables or specific views for the ML use cases, and then we provided the access from silver. Okay, so this is one of the most widely used, widely currently being adapted use case is preparing the data for ML and AI. Since now it's all Gen AI, everybody is building the Gen AI chatbots, Gen AI products, right? So everybody needs data for that. Your AI is as good as your data. Whatever you do, data is your raw material. So if the raw material is good, you can do a lot of things to get it to a finished product. If the raw material itself is defective, no matter how fancy or how innovative solutions, products you build, will still be defective, right? So the mostly adapted use cases these days is your GenAI. So you can also throw in something like, yes, we prepared data in the silver layer for the generative AI use cases like chatbot to RAG applications. So we were providing our organizational data from the silver layer. So you can say that, right? So that's one of the things that you should talk about that gives you credibility, saying that, yes, these guys have actually worked in the data engineering space on the data engineering use cases. Okay. So with that background, I will move back here. So we all know this is the Databricks community edition that's free. We have created our use cases. Sorry, we've created our accounts. So it has limited functionality, but enough to get us started with, right? So what we will do first, we have to create a compute. As we talked about, compute is your machines that is needed to run your jobs, programs. Very soon, Databricks is going serverless. So by default, everything will be serverless. So in future, you won't see creating machines on your own, giving the configurations on your own. By March, the default will be serverless. So everything, you just need to run the job and select, say, serverless. Databricks will take care of creating the needed machines with the power that is needed to process based on your complexity of the code, complexity of joins, complexity of the SQLs that you write, or complexity or the volumes of the data that you are processing, and how much data you are joining, how many tables you are joining, all of that. Based on that, it will automatically create the needed clusters online power with the power needed to process that. So that is serverless. So you don't need to specify it anymore. So gone are the days from initial when big data came in, we were trying to create the clusters on-prem. On-prem, you actually buy servers and then you configure based on your volume, your data. You have to purchase the server saying that, hey, I need 20 worker machines, I need 3 masters, and then you create configurations. I want 16 GB RAM or 32 GB RAM for each of the machine because, yeah, we want cheaper machines, and then we want multiple machines to connect to do parallel processing on each machine. And I want this much memory, RAM, these 4 cores, 8 core, 16 core, and all of that. There are a lot of complexity, in the 10 years ago almost, where everything we had to configure. And from there, it moved to cloud. Based on the cloud, then you had all of these machines where you can pick and choose and which configuration you want for the cluster, and the cloud will automatically create that cluster for you, and then you can use it. And once you use it, then the cluster will be dismantled. So it's like pay per use. You rent the machines or something to process your job, and then once your job is done, those machines are dismantled. So that was the second level of sophistication or advance that we had, and now everything is like moving on. Then we had elasticity. So let's say I said I wanted 3 machines, but then when I run the job, it is going out of memory. So then the job will fail. Then I come back and say, hey, 3 machines was not enough. Then I will add 2 more machines and then rerun the job. So level 3 was to take out that complexity and say elastic scaling. So auto scaling. So you choose that if it detects, so you started with 3 machines and then you're running the job. If it detects saying that, hey, the job is needing more power or more memory, it will automatically add machines. So it will scale automatically during the runtime. So at that time, so you can also set, right? So I want maximum to go up to 10 machines. So it will keep increasing, up to 10 machines when your jobs are running. And then once it is completed, then it'll scale down to standard 3 machines so that you don't get charged for all the machines when you're not using it. So that was level 3. Now level 4 is forget about all the machines, forget about auto scaling. You don't need to do anything. You just run your jobs. We will take care of making sure you get the required power or required cluster, required machines to run the job, from CPUs to GPUs, whatever you need right now. So that's where we are. But this is, community edition. As you know, you don't have all the features, but you can go, for the sake, you can create a computing cluster. Just click on go to compute, create a compute, give it some name. You can edit and give some name, and then configuration instance, right? So runtime default, leave it. It runs on Scala and Spark. Instance, you get free 15 GB memory. As a community edition user, it will automatically terminate after an ideal period of 1 or 2 hours. Then you have to rerun your then you have to recreate probably your machines. Okay, recreate your cluster whenever you come in, and then every time you create all your when your compute is gone, your tables are also removed, so you'll have to rerun and create. So this is just for practice, right? So it will not persist. It's like temporary. Okay, so go here, just say create compute, and then you will get this compute, 15 GB memory and 2 cores. So these are standard configuration. You don't need to worry about this. What are the notebooks that are attached to this cluster? Libraries, event log, what is happening when you run this cluster, when you're using this, UI, driver logs. There's a lot of monitoring stuff, right? When you use the cluster and run the jobs, you can see those logs. What happened when you run, how many resources were created, how many jobs were created, how much time each job took. All of those metrics you can see here. So that's the compute you need to run your job or notebook. Okay, that's all you need to remember. Now, while this is spinning up, we'll go here and look at our catalog. So catalog is just like your database. Okay, just think as it your database, which does not have any data right now or any tables right now. So once you create, your tables will be visible here. Okay, you need to create a cluster to access tables, so that we are creating. There will be a default database. So your cluster is created, and then you can create a schema under that, and then you create tables in the schema. Same thing, just like any normal relational database, MySQL, SQL Server, whatever. You can think of it same as of now. Then in future, then we will dig deeper into what Databricks offers as a database here, or how it stores data, how it is processing those things. Internal, that we will look at what is Databricks Delta, what are the features. So that we will explore later. But for now, just think it as a database. Now, compute is there, database is there. So what we will do, you want to see how to create a table. Okay. So you want to create a new table. You can get from S3, right? AWS. Since again, so one more thing I forgot to mention here is when you are creating this community edition, it will ask you on which cloud you want to create. So underlying, when I say it creates compute, it creates machines, Databricks is not doing that. It is getting the machines from your hyperscalers, your cloud infrastructure, providers. So the top 3 providers are your AWS, Azure, and Google Cloud. So you can run Databricks account or your Databricks environment on any of these cloud providers. So it can sit on any of these 3, and then it will interact with these cloud on your behalf. Whenever you run the job, it will go request, get the machines, run for you. So you pay Databricks, Databricks will pay some part of it to the cloud for using their machines, creating their machines. That's the business model. So it's the same thing. So you won't see any difference in Databricks, whether you run on GCP or you run on AWS or Azure, because it will take care of it interacting with those cloud internally. Since this one is on AWS, so you can read file directly from S3 and then create a table, or create table in notebook, or create table with UI, or you can upload your own file and then use it to create that table. Okay. So if I go S3, create table with UI. So it will ask for cluster and bucket name as of now. So we will explore once we go through cloud fundamentals, maybe tomorrow. We will start what is AWS, what is AWS cloud, what services it offers, what is S3, how do you store data in S3, all of that. So then we will come back. So if you say create table in notebook, it will throw you a sample notebook like this, where again, you just have to replace these variables. What is the file location, file type, schema, header, delimiter, and then run the job, all of this. Okay. And then it will store right to the table. Okay. Let's, we are here. Go back. Okay. So create table. Now upload file. So this is the standard initial path. It gives you file store dot tables where Databricks will store your files, whatever you upload, internally. This is the location, just like a Google Drive or something, some folder that Databricks will store. It's called DBFS, Databricks file system. Okay. So DBFS, it will store just like Unix. You store, it gives you some commands to view the files and to do a header and list and all of that. You can create any path here, and then you can upload your files and then use those files. Okay. So remember the path, go to catalog, go create table. It's just a hack. You're not creating table here. You're just uploading the file and then using it to create a file, create a table. Now file store slash tables. So let's say I create, I think training is already there. So let's say, I will just say Feb 2025. Okay. So this is my folder name. And then I want to drop files to upload onto this. Okay. So let me share, where is this? Okay. So when I click on this file, so it opens this folder. So here I have some sample files, employees, JSON files. There is a folder called movie lens 100K. So I open this, I have links, movies, ratings, tags. So I will use movies, open. So this file is uploaded. Now the path is this, file store tables, Feb 2025. And then you can use this to create a table. Okay, in notebook that we will see. It will just give you a template. You can do that, or the file is there right now. Then you can go to your own, write your own notebook to process that. So let's say I have a notebook called, the batch processing. So this is basically, as we have seen, this is our notebook to run all of this code for the ETL. So let's say we are doing, it's not displaying, that's fine. Medallion picture. I will show you how to show the picture or images, how to display images here. So we are reading CSV files, transform and load the data in the batch. Okay. Now, so this is the path. So DBFS utils. So sorry, in the DBFS, how you access this? It's called DB utils, Databricks utils dot FS file system dot LS. LS is list, right? And then you give your path like this. So here I have, what is my path? Feb 2025, and then I uploaded a file. So select resource. You need to select your compute cluster. So I use that cluster here. See, now it is connected to this notebook. It will use this to run this particular widget or this cell, this block of code. So here it is running. Now once it runs, it will show you some kind of jobs that it has triggered to execute these commands, these codes, right? So you have done display in Feb 2025 folder. You have movies.csv that we just uploaded, and then it will give you size, modification, time, name, and etc. So if you add one more file, so you will get that file as well. So we'll go back here, catalog, and then just say create table. And I will use the same folder, drop files to upload. I will use ratings. Okay, so this ratings is already uploaded. Now just go back, recents, go to batch processing notebook. Okay, now we will run this again. Okay, just run this again. Okay, now I have two files, movies and ratings. Right? So that is about uploading the files for practice. Okay, again, so anything that I do, there will be two different flavors, versions. One is for our practice. Okay, all local that we are doing, community edition and then file upload and all of that. In the organizations, you will not have use cases like this. Maybe sometimes you are just, maybe in development, again, you will use something like this during the development. But in production use cases, normally you have to read this from either S3 path, if it is AWS, or ADLS, Azure Data Lake, Azure Data Lake system for Azure, if you are using Azure Cloud, ADLS, if you are using AWS, it's S3 you can use, or GCP also, there will be something storage, Google Storage. You can use to read the files, or if it is a database, you use configuration to connect to database and read the data. That's for the use case. So right now, okay, let's say I have these kind of I have these path where I have these two files. Now I want to read movies.csv and then write it to a database. Okay, I will go here. I'll see movies, take movies, and then open. So this is my movies.csv. Oh, I already have it here. It has movie ID, title, and genres. Okay, 3 columns. And then it has data, IDs, and movie title and genres. So if you see here, the movie release or the year that movie was made or released is within the title itself, as part of the title within the brackets. If you see the genres, the same movie can fall into multiple genres. So there is the data, it's falling into 4 or 5 genres. You can call it Toy Story as adventure, I can call it animation, children, comedy, fantasy. It can action, thriller, comedy, horror, these kind of things. Now I want to process this data into my Databricks ecosystem. Okay. So now that is the file. How do you read the file? So I have it. Let's delete this. So you can delete the cell. Okay. So notebook. And update this. Okay. So in Databricks, we are using Pyspark, which means Spark is the library that was created by the Databricks team. So they are original inventors of Apache Spark initially, and then you come up with the Databricks company after that. It's been like 10, 12 years now, right? So Spark is the library that can do distributed computing or parallel in-memory processing. So we'll talk about all how Spark works, how it does distributed computing, how it distributes the processing to multiple worker machines and all of that when we do the Spark internals session. And how do you tune and all of that. So that you can use Spark on 4 languages: Java, Python, R, what is one more? Scala, sorry. Scala, it's basically written in Scala, but it runs on JVM. So Scala, Java, Python, and R. Out of these 4, the mostly used language is Python, followed by Java and Scala. So initially, Scala was preferred language, but then it came, Python took over, and now Python is the most favored language, most adapted language to do Spark or any of the data engineering, because most of the libraries in AI, ML, basically, ML or AI, are in Python. So Python has become the de facto standard to do any of the data, machine learning and AI. Since ML and AI are using Python, the data engineering side also kind of aligned with that to use Python as the preferred language. And we all know like Python is much simpler to use than write than Java. We'll not talk about power. It may be less performant based than Java, but that's fine. We have a lot of processing power, so that's okay. Now, Spark is a library, that object that we get default, and then we use spark.read to read a file, and then we have to give format. So format, there are different formats of files, we know, right? It can be a CSV file, it can read a JSON file. We will also talk about file types tomorrow. CSV, JSON, or Parquet files, arrow files. There are a lot of files that you can use to process. Again, mostly prominent formats are CSV and JSON. Okay. Any third-party vendors, if they are sending you files, it will be CSV or JSON, and even in these two, JSON is most preferred because it will have structure. You can have a proper standardization of the format in the JSON format. CSV is simple, but it will have some issues, with the kind of formatting and all of that. But we'll use CSV and JSON. Parquet is machine readable format. Humans cannot read it. It's a machine readable format file, Parquet, and that's what Spark also uses to store internally. Okay, but for reading, we will see CSV and JSON for now. So CSV, comma separated version of the Excel files. So CSV we'll use. Infer schema is an option. So when you use CSV, you have to give bunch of options, which will be used to read the CSV file. Infer schema is like, I can ask the program to check, hey, what is the each data type in the file? Is it a string? Is it a ID, or is it is it a number? Is it decimal? Is it date, or is it string? So we can ask it to automatically deduct based on the data. So it will scan the file, and then based on the data it sees, it will automatically deduct, hey, this is a string data type, and this is we are getting data in this column and all of that. Separator is comma. Sometimes, though they say comma separated values CSV file, sometimes they use a different separator like pipe delimited or something when they see there is already a comma in the text itself. Header is true. Why header is true? If you see here, the first line will tell me what is the header, what is the column names that it has, what data it is carrying in, movie ID, title, genres, kind of a thing, right? So that is, we are saying, giving an option, header is true, separator is comma, since the file has comma separation. Infer schema, we are asking it. I will also show you how you can give your own schema. And then we are reading the file. And then we also have to give the path, dot load, spark dot read, dot format CSV, dot option, infer schema is true, separator is comma, header is true, load file path. So what is the file path that we are using right now? What is the folder that we uploaded to? Guys?
So February 2025 something.
Oh, yeah. Yes, I need you to talk. I need to know that you are paying attention. Okay. Anirudh, Narsimha, Ramya.
Yes, Arun. Yeah.
Yeah.
Yes, Arun.
Just unmute and keep
Yeah.
talking time to time,
Yeah.
because otherwise it will become monologue. I don't even know whether you are there or not, right? Okay. So Feb 2025 movies.csv. So I'll just go ahead and run. Then I will display the data frame. So this is called a data frame. So whenever you read spark.read, it will return an object. If you see here, it's called data frame. It returns a class data frame reader. Okay. And that will give you an object called data frame. So this data frame is very simply put, it's just like a table. It has columns, it has data, it has schema. Okay. Columns with data types and data all together you will have in a data frame. Even in Python also you will call it data frame. You know, it's a pandas data frame. In Spark also you will call it a data frame. So simply we will display the data frame. Okay. I will go ahead first, clear the output here. Now I will run it. So now it is reading that CSV file, and then it is doing showing the data frame. So if you see that CSV file, whatever we have read, now it has read into 3 different columns. It deducted 3 columns. This is the headers, then ID, title, and genres, comma separated. Okay. So if you see here data type, you can see it is integer. It says this is string, and then this is also string. So automatically it has deducted. We have not given it. So everybody clear this part? Anybody? Any questions?
So I had a couple of questions. Maybe I didn't want to interrupt you in between earlier.
Go
So
ahead.
all these files that you had, are they
Mhm.
part of community thing, or where are you getting these files from?
No, I just
Sample data.
I just downloaded from the internet.
Okay, so we have to create the files ourselves. The community doesn't have these files.
No, I'll give you all of these files. I'll attach that. You can just download and use it. You can use any CSV file that is available on the internet, just for or Kaggle or anywhere you can find the sample files to process. You can use that.
Okay, and for the integer type, there are certain instances I've seen where mostly it's starting with a 0. Excel will drop that. And if you don't want to, you can force it to read as string, even though it's an integer.
Excel will drop it, right?
Yeah.
So we don't get Excel files. Normally, we don't read Excel files. We will only read CSV files. So CSV will not drop it. Though it is an Excel, CSV is a different format, right? CSV will more like a text. It is a comma separated file. So CSV will always have 0. But those are edge cases. First thing, if you have IDs integer, you can do that, or you can read it as a text, and then in the program you can convert from text to integer and then write Say if you're not able to convert, if you get invalid characters, you can throw error that I'm getting a invalid character in the integer column, though it is coming it as a string. So those are like validations that you build in the code.
And one last thing is, I know you said community drops this after an hour, right? You go through all this work, and if it's dropping, can you smooth it where all this is not listed, and you can start from where you had?
Okay, so yeah, community edition will drop basically. Now, all you have to do is create the compute every time you're going to practice. It will take 2-3 minutes to create the compute. Your notebook will still be there. It will not drop your notebook. Your code will not be dropped. Okay. Only your catalog objects will be dropped. There are no tables. But all you have to do is create the compute, go back to your notebook and run the notebook. It will get created again.
Thank you.
Yeah, that's all. Okay. Yeah, good questions. Yeah. Thank you.
So Harun, are we using the same cluster for the multiple files that we are adding?
Yes. So cluster does not have another good question. So cluster is just like a machine. Okay. It's just like your laptop.
Yeah.
Okay. It does not differentiate, hey, which file I have to run. Whatever file you give it to run, it will run. So you have attached cluster to this notebook. So you create another notebook. You can also attach the same cluster to other notebook as well. So if you go here, let's say I have this notebook, S3 example. So you can go here. Again, you can connect the same cluster here. Okay, and then use it. Normally, those are persistent. Once you create the clusters, what it will happen is it will be here. You can start and stop when you are using and you are not using. But since this is a community edition, you don't have access to restart this. So that's why what you have to do is you have to keep creating a new cluster every time you want to use. So that's the minor inconvenience that you will have. But anyways, is giving you all of this free to practice and learn. So I think we can live with that minor inconvenience.
Yeah. Okay.
Right. So coming back here. Okay, so we have read and displayed the data. Now, all of this, as I said in the previous session as well, reading a file, understanding the schema, parsing the columns, and then displaying it as a table, the entire file, everything we were able to do in just one line of code. All we are doing is spark.read and then path file. That is all we are doing. We are not doing any boilerplate code. These are all options that we are providing for it to understand what it has to do. But end of the day, again, this is all chaining, right? So all of this is just one line of code. So in just one line of code, we are able to read the file, parse it, understand the schema, understand the data types, put it in a tabular format and display everything in just one line of code. So that is the power of Databricks or data engineering with Spark, Pyspark that you do. So any organizations, so and then again, it doesn't care whether you have 100 rows or 100 million rows. The code will still be same. Okay, the computing power might change to process that, but to read and process that, it's still one line of code. So I have seen organizations migrate the data, okay, from lower environments or legacy environments onto a cloud, just under 20 lines of code, millions of rows of data. With just 20 lines of code, they were able to migrate it. Now, if we compare this with traditional or earlier programs that we used to write using Java and all, you may know how hundreds of lines of code, just boilerplate code that you would need to create and read and do all that file. Even if you use MapReduce algorithms and all of that with Java, it's still a lot of code that you used to write. Now with Spark and Python, it's just one line, or max 10, 20. Even the huge, if you want to do with transformations and in the gold, everything you can write under 20 lines of code. Of course, not with validations and all. You need to keep building on those, but basic, right? So just basic lift and shift kind of program code. You want to move data, you can do it with just under 20 lines of code. So that's the power that we are seeing here. Okay. Now, again, it has all the built-in power and features to understand delta data, right? So you can enable CDC change data. So it can also detect what are the new files that are coming in, which files it has already processed, which it needs to process now, new files only. And it gives a guarantee of process once only, so that you don't get duplicates. It gives features, everything on the cloud. If you enable cloud files autoloader, it will continuously poll your cloud location like S3 in Amazon or ADLS, wherever you have your files that are coming in. It will continuously poll and see, hey, are there any new files? And then it will pick up and process those files. And then it knows, hey, I have already processed these 20 files. I don't need to process them again. So I just need to process. So it will have its own internal registry. It will have its watermark where it has processed and what it needs to process next, kind of a thing. Okay, so that's the power of this one. Now, look at, so what we have used here is infer schema true. Okay, and header is true. That's what we given here. So a lot of times you don't want to do this, especially in production. This is not recommended in live use cases. For during development discovery phase, you can use this to see what kind of data is coming in. But once you have your schema fixed, hey, I am expecting these columns and these data types, then you can enforce your schema on that. So this is a Pyspark SQL types. Types is like data types. So you will have integer type, string type, decimal type, all of those for each data type. You can define a struct field and a struct type. So it's just a collection, like a group of columns you define as a struct type. And in the group, you define each column as a field. So my struct field will be movie ID. It will be an integer type. Title will be a string type, and genres will be string type. So these are the 3 columns that I will have, and these are the data types. True, false will tell you whether that column is nullable or not. True means it can be nullable. Like, if the file does not have value for it, blank for that field in that row, it's okay, it will accept. But if you keep false, let's say movie ID is mandatory, so then it will throw an error. If there is no movie ID, it will not process. It will throw error saying that this is a mandatory, just like your required fields, right? Mandatory fields. So you can configure that here. And then you can also write, when such error occurs, should you just skip that row and continue, or should you just stop all the processing and reject the file? Okay, so that's how it comes in production. Well, first you validate, you run the validate job, you run some of the checks on the file saying that, hey, is the schema matching? Is the count expected counts, or are we seeing a drop in the expected count? Or is the file in a proper format? Are we able to say JSON? Is it a proper JSON which can be formatted, or it's a bad file? We cannot read it. Format is not correct. You missed some braces or some commas in the file somewhere, so we cannot read. The program cannot read. So those kind of checks you will write first, and then when they all pass, you go to the next processing kind of side of it. So you are enforcing the schema here, and then you are reading the file. So this is another format of reading the same thing. So here also you read dot format CSV, and you gave options like this. This is one way of writing. The same thing, spark.read, you can directly say .csv instead of saying .format and then give a CSV. These are all different options that you can do. You can say read.csv, you can say read.json, something like that. You directly give the path here. I will say Feb 2025, movies.csv, separator, header true, schema is this. Okay. So I can run this again. See, we are only reading the file. We are not persisting or writing anywhere. So as of now, I'm just reading and displaying. So it's all in the memory right now. So again, you get the same data, no change in this. Okay. So that's how you read the files. So if you go here in the catalog, there is nothing. Still, we have not created any tables or anything. So we are still here. So the next step is, once you have read the data, I want to write it to a table. I want to persist it, right? So let's go here. Now, as I said, we want to create 3 databases or schema, whatever you call, bronze, silver, and gold in this. See how I'm using SQL here. Okay. So if you see this cell, this code block, it says Python here. Okay. So in the same notebook, you can switch languages. You can use Python, you can use SQL or whatever languages that are available, Scala, or they have removed Java here. I don't know why. Default. Python is default. You can use SQL, you can use Scala, you can use R. Okay. So you can mix and match within the same notebook. One block you can write in Python and one block you can write in SQL. And if any of the variables that are a data frame, they can be used across the cells in SQL and Python when it returns. So that we will look at later. But for now, say I'm here using a SQL to create database. So you have to be careful that every time you run, once you create, second time if you run, it will fail because it's already created. But if it is not persisted, so you have logged out and then tomorrow you came in and then you created new cluster and all of that. So then you can again run this to create the databases. So let me go ahead and run this. So this has run. Now we can go to catalog and see here bronze, silver, and gold. So these are all the 3 databases you can say, or schema you can say. In that, you will create the tables. So we'll go back here. You know what? Let me create another thing here so that I don't have to keep moving back and forth. I will open the catalog here. I will have this here. Okay. All right. So let's move forward. This is all I think, we keep repeating. Now, what I want to do is whatever I have written, I want to save as table. Okay, save it as a table. So for that, what I will do, I will take the data frame, which has the data, which is movies_df, right? Where is this movies_df? Yeah, this is movies_df. So this data frame I have taken. And then I want to write. So earlier, for reading, it's spark.read. For writing, you have to give what data you are writing. So data frame dot write. And then the default format for Databricks is Delta format. So what is Databricks Delta is something we will explore. So just write format, write.format delta dot mode. What is the mode? You can overwrite, which means it will delete the existing data and then write the new data in. Or you can say append, where it will just keep adding the data to the table. Then I will say save as table, bronze table name, which is bronze.movies. Bronze.movies is bronze is the database and movies is the table. You can call database or schema, whatever. Bronze database and then movies is the table. So it will write to a movies table in the bronze database, all of this data. So let's go here and run this. So this is just the variable name I'm using here, the same string here, whatever I'm using, bronze.movies. I can also take this and put here, just like this, same thing. Okay, I'll run this. So it has initiated some jobs to write that data from memory to the database. Okay, so this is done. Now, when this is done, we go and check the table is created in bronze. See here, the movies table is created. I can click on movies table, refresh. It will show me schema. What is the column name, data type, and all of that. It will show me some sample data in the database. So it will show 100 rows default sample data that you can see here. Okay. It will show some history of the table version. So basically it will give you the data, snapshots, history by default. So whenever you do something to the table, it will create new version, and then it will give you the history of that, what you have done on the table, the complete details of which notebook was used to do this transaction, which cluster ID was used, and then what are the operation metrics. This also we will go and read, one file, what are the output rows, output bytes, how many rows it has read, processed, all that data, basically metadata about the transaction, what transaction you did at that time. You said create or replace table because we didn't explicitly create a table, right? The first time when it say write, it will check, and if it is table is not there, it will use the metadata in the data frame because the data frame already has the columns and data types. It will automatically create the create the table and then put in the data. Next time you run, it knows the table is already there. So it will just write or append the data to the table. Which user was used to run this notebook or do this operation, and what was the timestamp. So, and each time you have a new version. So I will also show you how you can do a time travel in Databricks to go back in time and see how the table and data looked like at any point of time in history. So let's say I have processed for 20 days. Suddenly I see something wrong. So I want to go back and see, hey, last week, how the table looked like, how was the data there, what happened after that. So I can go back in time travel, go to that specific version, and then see the data. And then I can also roll back to that specific version and then start from there again, redoing the transfer, something there. Also, all of that we will cover later in the Databricks Delta. So that's the highlights. I just wanted to touch upon that. When you create the table, what are all the data it shows, the metadata. Now, once the data is created, you can actually use the SQL to query that table. So select star from, just like your standard SQL, table schema dot table name, bronze dot movies. So it will give you the data. You can see the data here with the SQL as well. Now, once you do that, there is another way of reading that same data into a data frame, Python. So you can use it with SQL. SQL will give you results. But when you read, just like, spark.read last time, you read from the file and put it in table. Now you can read the same data back from table. So all you have to do is spark.read.table and then give your, table name, bronze.movies, whatever. So just go here and run this. So you will get a new data frame again based on the data you have in the table, which is your type movies. The type is a data frame. You see from table, once you read, the type is data frame. And then this is the actual data. I'm just trying to show you how you can, play around with one data in a file. So now let's go. How do you create a temporary view within the notebook? So once you have a data frame, even before you write it to the database, you can simply create a view in the memory, just like it's almost like a table, but not in the database, but in the memory itself. In memory, you can create a table So you can say data frame dot create or replace temporary view movies underscore temp. So this is your temporary table, which is completely in memory. See, create or replaces a local temporary view with this class. So it's just local temporary. Once you come out of the cluster or notebook, this variable will not be, this view will not be there. And other notebooks cannot see this view. If somebody else is executing the same view, they will not be able to see it because it's only local to your notebook and your memory that you are using. Select star from, you can just write like a table only, even if it is in the memory. Sorry, I have to run. So table or view cannot be found because we have not run this. This was run sometime on October 26th, sometime last year. So we'll run this. Now this is created in memory. Now I can access this table. So it's the same data now in this memory also, in memory as a view, temporary view. Now writing this, the second step of it is doing the transformations, right? So the raw layer is done. Now I want to put it in.
Can I just ask you a question? Sorry to interrupt you.
Yeah, sure, go ahead.
When you created this view, temporary view, can you
Mhm.
query that also if you don't really want to create a table, save it? You just want to query it, do something on the fly, and then drop it.
Sorry, I didn't get your question.
So when you created this temporary view, can you query that view itself?
Yeah, that's what we are doing, right?
Okay, so if you query it, if I don't want a table actually created, but it's easier for me to query a view
Yes.
and drop it later on, I can do that, right?
You don't need to drop. It is in memory. It is automatically dropped.
Yeah. Okay.
But it will not be persisted. So next time you come in or somebody else want to see the data, it will not be there. But if you write it to a database, then it is visible to everybody. Anybody can read data from there, right? Yeah. So this is in memory if you want to manipulate. Say, for example, I'm reading 2 files, but I don't want to write that complete data to the database. I want to join those and then filter some data. And then I want to write that data into the database. So what I can do, I can just create some temporary view and do transformations and then write that. The second thing is I can do transformations on the data frame itself, but I have to use Python language. See, like this. Okay, this language, Pyspark language, to do the transformations. Since coming from a SQL background, so because everybody knows at some level SQL and they are comfortable with SQL, what I can do is just throw it into a temporary view. Then I can do all my transformations just using SQL. That will be easier for me. So that's why I prefer, once you get a data frame, throw it as a temporary view, register it as a temporary view, and then start using it with the SQL instead of data frame and Pyspark. Okay, that answer your question? Yeah. I believe yes.
Yes, thank you. Just
Okay.
give me a little minute to
Yeah. No, that's fine. That's fine. So filter data frame. I'm taking the movies and then I'm filtering it to get data where ID is greater than 100. So I'm filtering out the first 99 movies out. And then I'm only selecting movie ID and title. So I'm dropping the genre. I don't need genre, for example, just for the example's sake. So I don't need to carry the genre. If I don't want genre, I just want ID and title. Then I'm filtering this data frame where ID is greater than 100 and I'm selecting ID and title. So if I run this, you can see filter data frame will have movie ID and title where I have ID starting from 101. So the first 100 are dropped. Okay, title I have, and then I don't have a genre here because I have not selected this. Again, any transformation you do on the data frame will always give you a new data frame. Existing data frame is not change. It is immutable. You cannot make any change to the existing data frame. Any change you do will always create a copy and give you a new data frame. And you will still have access to the old data frame, existing data frame. See here, movies.data.df will still be there. If you display that, it will still have all the movies from one. It has genres and everything is same. So it has not changed. So there's something you need to keep in mind when you are doing a transformation. Which data frame are you using subsequently? If you keep using the old one saying that, hey, this has changed, no, it will still have the old data. Use the new data frame, it will have the transformed data. Okay, but you can still go back, and if you want the original one for something else, you can still use that. So that is the transformation part. Now, same transformation you can do using SQL, right? So I have registered the same data frame as movies_temp as a temporary view. So if when I run this SQL, what am I doing? Movie ID and title. Select movie ID and title is same as, let me just clear out for now. So movie ID and title, select, right? This is the syntax where you're writing the Pyspark. The same part is in SQL. Select movie ID and title from, here it is data frame, here it is a temporary view that we registered. Now dot filter, and this is the where class. Same thing here, where movie ID greater than 100. So for people who are already used to SQL, this looks much better, easier to do than this format. So you can just, all you have to do is one step, register the data frame as a temporary view, and then you can start using a SQL. And to tell you, it does not make any difference to the Pyspark environment when it is processing, whether you are using a SQL or you are using a Pyspark. Internally, it all is converted to SQL when processing. So this does not make any difference to the program, to the execution engine, in terms of either memory or in terms of either processing power or in terms of complexity, whatever. It does not make any difference. It will just parse this and then convert it into SQL and then convert it into internal processing language and then process it. So it's just for our convenience. It's okay if you want to write like this, or it's okay if you want to write like this, right? So now you can say, hey, this is a data frame. I can further use it in the cells below. But here, if I do SQL, it's just throwing me results. But how can I carry this into the next cell? So for that, it will give you something called a data frame again. It will display the results, but these results will again be assigned to a temporary data frame called _SQLDF. So what you have to do is you can just see the result is stored as _SQLDF and can be used in other Python cells. So that will answer your question. So in the next Python cells, you can just say display _SQLDF. If you do this, see, it will still be there. Or you can just say transdf. What's this? Transform df equal to _SQLDF. So that's it. You assigned it. Now you can use transform df as your new data frame. Okay. So like this, you can continue using that. Now there's another file called ratings.csv. Same thing. We can check tables. It's not in this. I have uploaded to Feb 2025 ratings.csv. Yeah, it's available here. Then I want to go and read the same file, ratings.csv as well, into a new data frame. I will remove all of this. I'll just say file location. I will put here. I will do CSV is the format. And then I will add info schema. I'll just change it here, change it here. I'll remove this so that we don't want to put all of this, looks complex code. So now the same thing, spark.read, CSV, infer schema, everything. There's a new file, ratings.csv. It's not movie lens, right? Yeah. Tables, Feb 2025, ratings.csv, and display ratings.df. So this is the data frame. It has a user ID, movie ID, and what is the rating that this user has given to this ID, movie ID. So what is this movie? We don't know. It's just an ID, right? So we have to take this ID to get what movie it is, take it here, and then go back and check what is my rating. Movie ID is Toy Story. So to get the information, I have to join these two tables and say, what is the rating that user one has given to this movie title. All right. So if you come here, so I have ratings table, ratings data, and then I'm registering it as a temporary view just to be, make it easier to join these two tables. And this is our standard SQL. Simple one. What we are doing here, we are taking name. What's the select? Title, movie stamp, select. Okay, so movie stamp is the movies table. So where we are selecting movie ID, title, and rating stamp is our rating stamp table. So we are doing dot user ID and rating. Okay. And then I'm giving this this table as movie name. Sorry, I don't need this. Just a rating from movie stem. That's what I was confused why I'm using that. Movie stem and rating stem joining on movie ID. Okay. So both the tables. So this is standard basic SQL joining two tables on the movie ID. So I got the two files. I read both the files and then I joined it in memory. So both of them are in memory right now. Rating stem and movie temp. So here now I can see for this movie, this is the title. User ID 1 has given rating 4. Same user for this movie he has given 4. For this movie he has given 5, something like that. All the ratings. Now basically it's a many to many. One user can give ratings to multiple movies, correct? And one movie can have rating from multiple users. Okay, so if you take one user, you can see he has given ratings for all of these movies. And then the same thing, if you go to different user, I don't know, it's, yeah. So if you go here, the movie ID 21, if you go to this user, this title, get shorty, this is given rating by user ID 4. And then he would also maybe given user ID rating from user ID 1 or something. So 5, 10 users, 100 users, whatever it is. So you will have ratings for all titles from all users. That's the basic information that we get from joining these two tables. Are we good? Any questions? This is basic SQL join only. We are doing in memory. Now the same join once I can do here, and then this is the how I write the same join using Pyspark. You don't need to do that. You can do in SQL and then use the same data frame. What are the columns that I'm selecting? And then I can do some transformations like with column renamed. So for title, I am renaming that column with movie name. So title will be renamed as movie name. With column, so this is with column renamed, and this is with column. This is adding a new column here called language, and I'm giving default as English. So there will be another new column with language as English. Filter, again, I'm filtering that entire data set where user ID equal to 1 and movie ID equal to 1. So basically I'm writing that. So you get one row where movie ID is 1, user ID is 1. So this user for this movie has given this rating. So the language we have added default English. And if the column name, if you see, it says, it does not say title, now it says movie name. So these are the kind of transformations you do. In source it, the table name or the column name can be different, but in our schema in target, the column name may be different. So you can rename the column to match the target schema, or you can add new columns. So once you do that, same thing you can also do in SQL. Select column renaming, you know how we do in SQL, title as movie name. That's it. And then we are adding new English as lang, and then same join, and then where class. So if you run this, you will also get the same output. We have to use the proper in-memory view names that we have. Rating stem and movie step, right? I will use, oh, not this one. Rating stem. Movies temporary views. Dot. Okay. M dot movie ID equal to R dot movie ID, right? Column or function parameter with name M cannot be resolved. Anybody? Can you see what the issue is? Let's see why it is calling. Did you mean M dot, see column name, I'm using movie underscore ID. Now it is telling me an unresolved column. It does not find the column. M dot movie ID cannot be resolved. It is also suggesting, hey, do you think it is M dot movie ID like this, or dot movie ID like this, genres, title, user ID? Do you think is this the correct one are you using? So yes, maybe I'm using movie and movie underscore ID. Let's see this. Movie ID, and then here also let me see if I'm using. Is this the one correct? No, it's not. What are we using here? Let's go back and see. Rating stem. Okay. Select movie stamp and rating stamp. The ID is correct. The ID. Now what? Okay, here also we have to change. I don't think the case will matter. VID is ambiguous. Okay, let's select M dot movie ID since it's there in both the tables. Okay, right. So it's a standard SQL using movie stem and rating stem in memory, joining these two on the movie ID. So you just have to see, what are the column names that we are using for these temporary views that we have registered, that tables. Or you can just write a select star from statement and see what are the column names and use those column names here. Basically, yeah. So this transformation that we have written here, column renaming, adding a column, doing filter where clause, selecting the columns, joining. So everything, all of this, you can write using SQL, and then the underscore SQL df, whatever you get, is the same as your joint df you get here. So both represent same data and same schema. Okay, so we are kind of running a little bit over time. I'll just take another 5-10 minutes. So this is the join transformed data frame again. So what I'm doing, same. So this is the same thing, but here column renamed, title movie name with column release year. So now what I'm doing, so if I look at the data, the release year is part of the movie name. So what I can do, I can write a transformation to pull that out, release year, into a separate column, right? So that's what is needed. If I want to do any aggregations, hey, for example, what are the movies released in 1995? So I cannot write a where clause because it's part of a string. So it will become complex. So what I will do as a part of transformation is I will split it and then put it in a new column so that it is easier to query the table. So how I am doing it? With column release year, substring from movie name, start from the end, minus 5 characters, and take the 4 characters. Basically, it's saying you start from here, count 5 characters, 1, 2, 3, 4, 5, where you will reach this starting point of the year. From here, take 4 characters, 1995. So that's how you have written the substring function here. So don't worry about all of this syntax. You can easily get it online. AI will generate the entire code if you want and give you, but just understand the logic. All you have to tell is, hey, my year is in the end of the string in the braces like this, extract the year from this. So this is a substring. -5 from means from the end, you are counting backwards 5 characters. And from there, you are taking the next 4 characters, which will be my year. And then I'm putting it in a column called release year. So this is release year int. For that, again, you will get as a string, and then you are converting it to integer. Okay. So then you can display the final data frame here. So let me run this. Okay. So now you see movie ID, movie name. Though we have taken year, we have not changed the existing column. So that will still be there. Genre will be there. Rating user ID. See, there will be another new columns, release year and release year int. And look at the difference. This release year is a string. Now, after we converted it to an integer. This is an integer column, release year int. Okay, so you don't need duplicate data. You can just drop this column. Drop means you can select some columns from this, and if you skip this column, you will not need it. So you can just select title, genres, rating, user ID, and release year int. And create a new data frame and then write it to the database. This is again in memory, same this data frame. I am writing it, creating it as a temporary view, something in the movie's final, and then you can write your SQL here. Okay, so you can just say %SQL like this, and immediately it will change from Python to SQL here. Or remove this, it will move to Python. You can go here and just select I want a SQL. So it will automatically put SQL here. Now I can just say select star from where is this? Movies _ final. See, now I get all this data with the release year and release int, because I am reading that data from the temporary view, which is in memory, which I have registered using the data frame. Now, once I get that, I don't need this database silver. We have already created all 3 databases. So I will delete this thing. Now take this data frame, write again delta, overwrite, option merge schema true. This is something we will discuss later, why we need this. If we are changing the schema, adding, removing columns to this, and then save as table, silver dot movies _ final. So I can run this and it will get created. The table gets created on this. Okay, so that is done. We will go here, check catalog, go to silver, says the movies final is created. Go here, refresh. There's a schema, release year is there, string release year int is there, and then there is a sample data here. So this is how you write your transformed data into silver. Now, if your machine learning wants to see, hey, what are the top 5 ratings or top 5 user IDs who gave this rating? What are the top 4 movies released in 95? Which movie got the highest rating? Which genre movies are trending in the recent past, in the last 2 years, 5 years? All of this analytics questions that the business needs will be answered, can be answered by writing queries on this. Of course, you still need more transformation, like, comedy, romance. So let's say I want to get only comedy. How do I do it? So you can still have to split this row into 2 rows, one as a comedy, one as a romance, so that it gets counted in both when you're doing any query or analytics on this. So that kind of transformations you still need to write. And then maybe you want to strip this year from here, or maybe somewhere the year is not given. How do you handle that? If in the title there is no year, so you might get some junk data here. So for example, I think there will be some junk data. Let's see if it has or no. I'm not sure. See here, for example, in the movie's final, there is some data, movie name called Black Mirror. Let's take this, go here, search for this Black Mirror. What happened? So this Black Mirror didn't get processed properly. So it got broke here. So in here, it took only up to this point, didn't take this part when it read the file. So the last 4 characters or 5 characters, it became some IRRO something, some junk data, something happened. Some edge cases like this, you have to maintain and manage. Oh, not this one here. Why am I looking at the wrong one? Yeah, see here, 176601. 176601. Movie name is Black Mirror, but there is no year and there is no genres here. So this is the kind of issues that you might get when you are processing. So how do you handle this? So these are the kind of rules, business rules or validations that you have to write, because now it will become irrelevant data here. And then see, release year is null. So what you can do once you parse data, then maybe you can run a SQL saying that, hey, get all the rows where release year int is null. So that will give you some sense of bad data. Then you can report it back to the source saying, hey, I'm seeing bad data for these rows. You fix it and send it. So that's the validation that you do, those kind of things. Any questions on this? Up to the transformation and silver, I know we're not able to get into the gold aggregations. We can continue in the first part tomorrow before we moving on to the cloud platforms. But at least we covered the ingestion, files, ingestion, and silver layer. Right? Any questions?
Thank you, Arun. No questions from me.
Okay, awesome. Narasimha, Anirudh,
Good from my side as well, Arun.
everyone?
Harun, it was pretty clear. Yeah,
Okay.
no questions from me.
Ramya, Ishrat,
Yes, sir. Yeah, I'm clear.
okay. Ishrat, Nabi, all good?
Yeah, yeah,
Okay.
I'm good.
So I'll publish this notebook. And I think I have already shown you how to import this. You can go to your folder anywhere, right? So if you have a folder here like this, right click and say import and say URL. I will publish the URL to you. Put that URL here and click import. So that notebook will automatically come into your folder. Then you can open, create your own compute, attach it to the notebook and start executing cell by cell. And I will also give you, before end of day, the files that I'm using. These files I'm using, I will share it on the drive. You can download it and then go back to your here, as I've shown you, workspace, go to new, no, not new. Sorry, catalog. So go to catalog, create table, put your path, and then go to files and then upload whatever I'm going to give you from your local. And make sure you replace whatever path you put here in the notebook so that you get the correct path. Or you can use the same Feb 2025 when you upload that folder name so that you don't have to change the path. All right. That is all for today. I know I've taken 15 minutes more. I wanted to get it to a logical stop. So we covered the bronze, the transformations, and the silver layer. Please go through it. You have time. And then we will come back. Tomorrow we'll complete the aggregations part, the gold layer. And then we will start about the cloud platforms. What is a cloud platform, what is storage, and some concepts, how to connect to AWS, what is S3, how do you store files in S3 storage, that we will get started tomorrow. And we will be like moving between Databricks and the cloud so that we don't get into a rabbit hole too deep into something. We want to get all concepts covered parallelly while you get time to practice these things. All right. Thank you so much. Appreciate your time. We'll meet tomorrow then. Have a good day.
Thank you, Arun. You too.
Thank you.
Yeah.
Thank you,
you.
Harun. Have a good day as well.
Yeah, take care.